Hello everyone, welcome back to another episode of the Reliability Gang podcast. Hope everyone's having a great day. I'm back with my right hand man, Will. How you keeping, buddy?
I'm doing really well, thank you ever so much.
And today we're actually in the studio. So my current studio, well, I've moved house recently, and my current studio is under construction. So these podcasts are going to be done here temporarily until they're sorted out. But it's quite nice in here, it's quite cool.
It's very cool. It's my first time in here. We've got AC, we've got all the soundproofing on the walls and all the gear to allow us to create the podcast in that high quality. I think we've noticed recently since you've moved, the quality just hasn't been as good as we want it to be.
Yeah.
And
definitely.
so being able to utilize this space and be able to just come in and grab all our stuff and do it is going to be really, really looking forward to that.
Yeah, definitely. And again, obviously we've obviously we keep doing this, we keep dipping out, coming back again, making loads of podcasts, and again, it's been quite difficult to make. We say this every time.
It's challenging because you're trying to grow and develop his business, and we've got a lot of guys that work for Maintain that we're doing a lot of training with, which we really enjoy that. And we really enjoy doing the podcast too, but no matter what, those guys always come first. And so this is always tends to be, unfortunately, the first thing that
I know,
drops.
and it's horrible because I do get messages regularly to say, "Oh, when's the podcast coming back? When you guys back on?" And I think we have created a really cool thing here. So I made a bit of a pledge actually, and I was like, "Right, Will, we're going to get to the studio early today. We're on site after this as well, and this is the crazy thing. This never ends for us. No. This is the only opportunity we've got." But I said, let's just get a couple down. We've got a lot to talk about. And I feel like because we've been away for so long, I've got all of this energy that I want to try to put out there to the industry as well, in terms of a lot of subjects that we're doing, a lot of realizations actually that we've come across. And me and Will, we talk every day. We're like best friends. But within the reliability game, we're like best friend reliability friends as well. So we'll have in-depth discussions about the industry, kind of what's going on, the experiences at either or customers and stuff. And I think we've unearthed quite a lot of cool stuff recently, haven't we, in terms of our conversations. If only we could record
the conversations we have in the cars. The car is like our office for me and Will, when we're always traveling to site. So we're always we'll do a ring round to all the guys. So we'll ring all the new guys that are on site. And then I will always end up with our phone call, which will be like an hour where we're discussing setting the reliability world and understanding new things, or what about this, or what about that. And it's really good just to brainstorm all those ideas and see what we both think.
Yeah, definitely. So today, today's subject is more about observations in the field. And obviously we was talking, again, what's inspired this podcast is that we had a conversation on the way to work the other day. I kind of explained how when I first learned, and again, because we're obviously training a lot of the guys within our, organisation, how to get to the next level of vibration analysis and more observations. Because I think when I first learned, I don't know about you, Will, I was very heavily reliant on the data, and I was very kind of collector bound. My head was always in the collector, trying to understand what was going on. And I wasn't doing enough of the observations around the machine, feeling the machine, feeling what potentially could be wrong and using my senses around it. And I think a lot of people do start that way.
Yeah, I mean, a big part of this started, we've got a new engineer that started with us this week, and he was talking to me and Will about, how do you guys just, can just rattle off what you think the fault modes are, and how do we come to those conclusions so quickly when we're doing a lot of in-depth analysis. And I think that's kind of what derived the conversation, because it was actually we don't really do that in-depth analysis. We're looking at more observation-based and then using the analysis to confirm that. And I think for anyone listening as well, if you're an engineer or an engineer manager at a site where you don't do any condition monitoring, I think this topic really applies, because I think it's so easy to forget about those observations. And they're actually, when they're done and implemented correctly and in a robust, sustainable way, can be very effective at finding
massively effective. And I think that's the thing, isn't it? Again, when we learn this really in-depth subject that's called vibration analysis, it's in-depth, isn't it? It's a lot to think about. So again, I think we can get lost within the technology and the understanding of spectrum graphs and stuff.
Especially when the majority of the fault conditions we're finding on a day-to-day at site are what we would call in vibration analysis low frequency. They're structural related, they're misalignment, they're loose, they're imbalanced. The complex faults, where they do require that in-depth analysis, you don't really come across those too often.
No, and until actually it's too late, really. Because I think when you're talking the high frequency vibration that we can't, audibly hear because it is that higher frequency, that's when I think the collector does come into a league of its own. Do you know what I mean?
Definitely.
I really do think that's the part of the actual value what the collector brings. Because a lot of the time, you're right. If you go to a machine and it is vibrating and it's at a low frequency, you can kind of
feel it, can't you?
Feel it, but not even that by process of elimination, understanding what the fan's process is or what its function is.
Yep.
It's trying to then deduce, well, it can't be this because it could be that.
Exactly.
And again, there's a lot, again, I think obviously VA is incredible, MA is incredible to see it again. But again, if we can become better observers of the machine, understand how applications run a little bit better from the get-go, then all of the tools that we add on to what we're doing are going to end up just being more of an assessment to you as an engineer in terms of observation.
I think definitely, because the majority of time for me in particular, and I think you're probably the same, Will, is the analysis and the data collector is, for us, with our engineering background, is more of a confirmation piece. For some of our guys who haven't got the mechanical or engineering experience, they're very reliant on that data.
Yeah, 100%.
So for me, or for those guys, they're collecting the data, they're looking at their analyzer like, what's the problem? Whereas for us, and as we're teaching the guys this mechanical knowledge, it's more of a case, okay, I've got, I don't know, a fan, and this fan is moving air from A to B. Well, okay, it's direct driven, let's just say. We can list in our head what ways this could potentially go wrong. It could be out of balance. It could be misaligned. It could be loose. And eventually you build a picture of maybe 6 or 7 potential problems that could occur with that machine.
We're almost doing like mini Famikas in our head, aren't we?
Yeah, kind of.
Kind of like saying, well, how could this fail? How is this
and
machine?
how would I detect it? Because you'd sit there and you'd be like, okay, like the fans we saw the other day with the customer we were at. So we looked at the machine and I was trying to teach one of our guys, David, analysing this machine. And it was a fan and it was belt driven. So we were looking at the fan and we took some measurements off the drive end of the bearing, and the analyzer went velocity in alarm, 8-9 millimeters per second. So I said to David, I said, well, we've got to think about the application. We've got to think how it's working. So even without having that information, let's have a look around the machine. Okay, we can feel it's vibrating a little bit more than normal. We can feel the temperatures on both bearings. We can feel the drive end is a lot hotter than the non-drive end. And we can start pointing ourselves in directions of, okay, well, maybe this is more misalignment potential problems.
Yeah, 100%.
And then all the analyzer then does is confirm which direction the machine's moving, because that's one thing we can't do just by looking at the machine. And then we can go, okay, that is this.
That's the confirmation bias that we need to obviously make them decisions and understandings. And I think, to be honest, I mean, the Falcons have revolutionised this for us as well in terms of that extra part of information, because before we didn't have the time to be doing axial, vertical, horizontal readings on everything. We just didn't have the time. And not even that, the collector was slower.
Yeah.
So now we can actually get, all of them readings in a quicker fashion, twice as quickly, because it doesn't multiplex. I mean, look at that type of information now that we've now got, that I almost feel like we've not neglected, but we've been spoiled.
We forget, doesn't we?
Yeah, you forget how valuable that is. And then looking back at my previous, like my early start within this, I mean, the collectors we had were very powerful, and they did ultimately the same thing as what these can do. Of course they do. But these extra added features in the analyzer in terms of speed and that allowance to be able to have 3 axes simultaneously and be able to view each axis in each spectrum and see what's going on one screen to compare against all 3 axes and have a look at the different frequency sets. I mean, how powerful is that?
Well, that's the thing. Like this fan as an example that me and David were looking at, like when we used the previous data collectors, we wouldn't have took axial readings on here.
You wouldn't have done it.
Primarily because...
And I know what everyone's going to say, though.
You wouldn't have got the sensor in.
I know, but I know what everyone's going to say as well. Oh, you should be doing this, that, whatever. But we got to look at this in a practical point of view. Yeah. Like, would you take loads of action horizontal readings when you know that you're going to miss another high percentage of assets by doing that?
Because it's taking you the extra time.
Exactly. And again, I think everyone wants to live in this ideal. We don't live in an ideal world. And if you've got a customer that's like, right, I've only got 2 days.
It's a risk-based, isn't it? So you've got a unit and you're like, okay, what's the risk of us not taking an axial measurement? Actually, the risk isn't that high, because generally what you would do is when you find a problem, you may then say, okay, I'm going to take an actual reading.
But, well, what is the adverse risk of taking the actual readings and then not taking data on another 10 assets that you haven't tested?
Exactly.
We all know the risk is higher there. And again, this is one beautiful thing the Falcons, the Echo and Falcons have taken away. Yeah. That even having the choice of what to do,
Having
because
a
it just does it.
triaxial sensor is so powerful, more so than you initially think. And even just thinking in my head now, I was thinking, oh yeah, because if I didn't have a triaxial sensor, the fan the other day, I wouldn't have even been able to take an axial reading because I can't, because the guard's up against the bearing.
Exactly, you'd have had to do it in a weird way.
I'd have had to put it in reverse or something like that, or if there was a guard, it would have been made it very difficult. But by us being able to take that axial reading, it changed from, okay, I think it could be misalignment, to we're very sure.
We're again 90% sure misalignment. Obviously, again with VA, you're never 100%. There's always something in there that
throws you off on your toes a little bit.
Well, I've been around the block. I know this game. I've been there. You know what I mean? But again, this is the beautiful thing again. But again, it's still observation based. So as much as that kit collected gives us the information that is so valuable, again, we've already kind of come to our conclusion, or an assumption, shall we say, about what the machine condition is before we even look at the data collector itself.
And I think this observation and this inspection, I mean, where I used to previously in other employments, we used to call them audio-visual inspections, where we used to walk around with temperature guns and inspect the bearings. I think this is a really quick win for a lot of sites to implement, because it's now covering a much bigger range, not just vibration analysis. So auto lubrication systems, another one that we're seeing become more popular because they allow for a much more better option in terms of lubrication. But that comes with the fact that we still need to do observation to check their field, to make sure they're functioning. And the same with wireless systems. Wireless systems are becoming so important, and they are great bits of kit, and they allow us to take more readings.
Without looking after them. And this is, again, how much, like I've seen example. I'm not naming any names, but I kind of, within this industry, I go off what I hear and what I experience. And we're seeing the same patterns in certain areas, you know, for all of these kind of autonomous systems that are put in place. But if there still needs to be some sort of control on the autonomous systems. And it was actually a really interesting comment that one of our engineers said to us. He said to us, we'll always have a job, because no matter how autonomous things get, autonomy needs to be
maintained.
And that made me really think about the whole concept of the industry we're in. It's so true, isn't it? How many times, Will, have we seen a site that has said blank, well, you know, someone's gone in and tried to sell them just product and say, right,
these are your sensors, strap them
on. Or not even that. How can we improve product sales? Lubrication. So they might be thinking in the right direction of like, how can we solve a problem? But again, it's more driven upon how many units can we sell them. Do you know what I'm saying? Rather opposed to how do we get this right? And how many times have we seen a site just, you know, whack self-lubricators on everything and
forget about them.
It's the solution to all of their problems.
I went to a site the other day, and I'm doing the inspection saying, guys, the auto lubes, they're empty.
Yeah,
but how long have they been empty for?
I know, but that's such a, you know, they're empty, so they're not getting lube, right? On the other side, right, I've been to a place, and me and Jamie up north have actually done a shutdown there, right? And we found that these auto greases that they installed, right, they're just continuous feed ones. And again, they're doing a job, aren't they? But whoever it's down to whoever sets them up. You know, again, they've been sold them, installed without any correct lubrication amounts. We had to repack 5 fans.
5 fan bearings.
Did
you open them up and they were just like...
Open up, absolutely caked. We've got images and everything, right? I might even put a few into the video here. Do you know what I mean? Because we've got video now.
Yeah, we have
amazing. Like, this is crazy. We've never had the opportunity to do this. But so I'll put one in. But as you can see with the pictures, like, honestly, the soap, right,
just completely separated
from the oil. And you can just see that the darkened soap is obviously where the oil's separated from. Yeah. And it almost comes like this sludgy kind of, it's not even really grease anymore, if that makes sense, because the properties of that have completely broken down. And you get this sludge in there, and then you get more in, and the same thing happens to the grease that's going in. Then you get this horrible scenario where you've got an over-lubricated bearing, but the bearing's not actually creating any film, because there's no oil in it. It's separated. So and again, this is where people get really confused, because they're like, oh, you know, it's over lubricated. How can it get hot? There's loads of lube in there. But you have to understand that the whole component of the grease level is the two things combined, obviously, to hold that oil to create the film.
Yep.
So when you get this over grease bearing, what you get is overheating of the bearing. That's the number one typical sign of it, first of all.
Yeah.
Obviously, second sign of it, seeing it come out of the actual seals and pop the seals, because that's the second part. But again, before it gets to that part, there's a lot of early signs of it. So, but the problem is, engineers will see, the bearing's getting hot. Oh, I need to go grease it more. Yeah. Then they'll grease it more.
And make the situation
then they're just
worse.
continually making the situation worse. But I mean, what we did, as soon as we took the caps off and repacked the bearing, take all the sludge out, and then just put a nice little film on top, obviously do it very carefully, because again, it's never great practice to do this. And this is why it's important to get it right in the first go.
Yeah.
Because we shouldn't have to be doing this, right? But in terms of a remedial for this type of action, right, once we've done that, the reading dropped significantly and the temperature did straight away. Within literally 2 hours, you can see the difference. Yeah, it's crazy. It's mad. And, you know, we're seeing this as a common problem. Now we're having to fix all of these bearings because, again, on our collector, we've got something called lubrication factor, which basically looks at the frequency you would expect to see that metal-to-metal contact at a high frequency. We've got an article on it as well. Very effective reading that allows us to quickly identify there's a problem with lube with an overall alarm, and then we can look into it. That rings off massively with an over lubricated bearing as well, because the over lubricated bearing, you're not
still
creating the film.
You're not friction, isn't there?
It's friction. You're not creating that film. There's loads of grease in there, but you've put too much in there, so it can't maintain the film.
Yeah.
So, you know, this is the thing as well. We have to be careful that when we do see lube factor, we ask the question, has it been over lubed? Not just add grease. And I think the good thing is about what we can do, we're in that live mode, once we've added grease and we can see the difference, if we don't see the signs of overheating, if we don't see the signs of like over lube in terms of coming out of the bearings, and we kind of need to deduce whether it's under or over lubricated, as soon as we put grease in there in a live mode, we can see it very quickly change.
And like talking about lubrication, lubrication's a really quick way if you don't have automatic lubricators. But if you've got a guy walking around site lubricating your assets, they can be making observations at the same time. And it's about when we look at observations and making observations and setting up PMs for inspections and things like that, there's a lot of inefficiencies that come with that. And part of like the reliability aspect of it, which we'll probably talk about in another podcast, are things like PM optimization. Like, how do we look at our PMs? Like, do we really want to have 3 PMs? One guy's walking around lubricating, one guy's walking around inspecting, another guy's checking all the auto lubes,
and another guy's checking the bells on the same assets.
And the same assets. Whereas what we can do is actually look at the PMs and be quite effective with them and have them kind of rolled into one. Maybe keep them separate still, but have like, this guy is running these 3 PMs. They all require me in the same
He kind of runs that route, and within that route, he will check these things. Yeah, I think it's been aware of them things and rolling all that whole PM into one.
That's it.
I think a lot of sites do that, they'll save a lot of time, because I think the majority of sites that we go to, I don't think they've, even though the PPMs are very important, of course they are, they're always going to be. But the fact is, are they efficient? That's the question.
Yeah, and effective, because you've got, it's important that a PM is descriptive, it's detailed, and it explains what you're expecting.
What are you actually doing?
And not just, I've seen so many, it's like, check the fan. What do you want me to do? Yeah, still there.
And you can just see someone going around. Yep.
And then it just becomes a tick box exercise. And so
I don't like that.
There's important things to do, which is, okay, let's say we've got a fan and it's got an auto lubricator on. Okay, so what are we checking here? And a lot of these checks might come off the back of a Formica, where it helps you understand what you need to check that may be undetectable through VA. So it might be, okay, we've put an auto lubricator on because we want to effectively lubricate, but there's nothing that's going to be able to tell you when it's empty. So we have to do a visual check when it's empty.
You have to look at it and say, has it got lube in? Yes, it has.
It has. And then we have to state within that PM, at what level do we want the technician or the engineer to raise an alarm? So we say, okay, I don't know, if we've got maybe one of the G Lube 250 mils, we may say, right, we need an alarm raised or a work order raised when it's at 100 mil.
Yeah, because like a metric to understand.
It has to be a number
action is taken.
Same with with vibration analysis. Although generally when we're doing it for customers, we might be completing one of their PMs, but for us, we say, right, if this goes above 0.6 Gs for us on our analyzer, that is an alarm. And if you don't have that, you've got no metric for anybody to work against. Yeah. And so, if you're doing things like pure inspections, auto lubricators are on your fan, we can be very clever with this whole idea of PM optimization. There's a whole topic in ARP.
We could talk about PM optimize. That could be a completely separate podcast.
Yeah,
because it goes massively in depth, especially about really culture as well. It is simple, but it's very difficult to change. Like
it can be,
I think, to be fair, we could go into a site And we could do that.
It is, because
we could do that
essentially,
very well.
like PM optimization in its most broadest sense is look at your PMs. If none of them are specific, get rid of them.
Yeah.
And for a lot of places, that's like,
whoa. It's just too much. It's like, I don't know, it's a fear. It's a fear. Like, oh, if we stop doing that, if something fails, then it's on us type thing. And I think even some people know, even in the engineers, like, I can't believe I'm doing this.
But that boils down to understanding, again, the machine, understanding the failure modes, and then going through them. Imbalance, or how do we detect, like real basic for Mika, imbalance, how do we detect it? Vibration analysis, we're doing it every month. Great.
Yeah, but not even that. It's a fan. Okay, is it like moving product? Okay, it is. Right, let's check that fan every month, clean it. That's a PM that can be done.
Yep.
And again,
especially if it's a product by which that we know it's going to
stick.
issues.
It's going to stick to the fan or whatever.
But then you have like the next big piece after that you can do, and this comes down to probably our next podcast where we can look at things like, well, we're cleaning it every 6 months. Do we look at the cost of that, do some data analysis, and go, well, actually, it's probably more cost effective for us to buy a coated impeller.
Yeah,
might be an extra 3K.
But the time it takes in terms of disruption as well. That's usually the biggest one. Yep. Is it going to disrupt the process? Can they even shut it down?
Yep.
There's some fans that run 24/7. Yeah, I'm running forever. I'm never shutting down. And that's the thing about fans.
Yeah.
They're very kind of a 24/7 running asset that is very dangerous. Yeah. They run very fast, and they're very important to process.
And I think
that's why there's so many of them around in these factories, mate.
And I think, like, to as a bit of a summary to the whole, like, this podcast in terms of observation and doing that, I think it's just, it's really key that we keep the guys, any technicians, engineers, even ourselves, going around looking at the assets. We can support anyone that wants help with PMs and in setting up these inspections. But it's also important to remember one thing that I was always made aware of. It's very easy, and I think this is where it's quite nice when you've got maybe a contractor coming onto site to do some type of reliability or inspection work, is for the guys on site, it's very easy the term that I was always made aware of is to become what's called fault blind. It's very easy for the guy that's doing the same route every month to walk past that, I don't know, leaking pipe and be like, it's okay, it's always been like that. It's always been like that. Whereas it's very important to rotate fresh eyes. Like, this is there, that's there, this is there.
Yeah, definitely.
So I think, observation, inspections, PMs, they're really important parts of any reliability program. There's just ways to implement them to make them very effective. And sometimes it's always worth just having someone come in and have a bit of a review and be like, well, actually, if you did it like this, you're going to save yourself this much time, or you're going to make it this much more efficient.
And I think that's it. What you explained was perfect in the sense that when you get someone else to have a look, they will identify areas where you was like, how did I miss that? You know what I mean? And I think that fault blind is a real thing.
So easy.
Genuinely think it is. And I think it's for us as well.
Yeah, we can.
That's why sometimes externally, someone who has a view on terms of the business has a real valid points. Do you know what I mean? Like even my partner, she's a director as well, but she's not massively involved, but sometimes she makes an observation and it's like from an external place. I'm like, my God, how do we miss that? So again, the same thing applies to everything. So it's always really good to get someone else to have a look at it. And even if you just get them to have a look to see if, and just try to prove yourself wrong. Do you know what I mean? And I think that's, if we can try to prove ourselves wrong that, it's something that we think we're doing right, we're doing wrong. They're the hard things to change. Yeah. They're the really difficult things to change because they're ingrained in culture and kind of almost ignorance, right? The stuff that's easy to change is the stuff we're aware about and we're quite willing to work with. You know what I mean? Yeah. But it can be very hard and frustrating when you go to a certain organisation who think they're doing it in a way, and it's almost delusional to a degree because they're like, well, no, this is the way. Yeah. And it's like, but they will not even entertain any other, and it's difficult because we've come across a few customers like that who have, and all we're trying to do is give advice about it's a perspective thing, isn't it? It is.
And I think like something else that I was always told, and we implemented at one of my last places that I thought was actually quite effective. I've not seen too many people do it, but it really supported morale as well and culture change, especially when you're trying to do a reliability journey, is what they did is the kind of senior managers within the engineering department. So they had the engineer manager, the reliability manager, and a few other people. What they did was they actually did morning walkarounds themselves. So they each picked a little area of the factory and they just walked around themselves. They're little engineers, your reliability manager knows what a problem looks like.
Yeah, they've been there before somewhere, haven't they? They've rised through the ranks, so probably,
These are guys that aren't generally out on the shop floor, but what it does is it allows them to engage with the guys. It it allows them to have a look, oh, what about this? And then they can spark a conversation. It keeps them a bit in the loop as well. And I always thought that was quite effective.
I think so. I think it's great. It's great to have that presence in terms of higher management looking around as well.
Yeah, because then you're not just the guy that's in the office.
Yeah, I know, and that's the thing is the guy in the office is doing a lot, and again the perception from the people that potentially out grafting is probably, oh well, he's not doing a lot, but again I've seen it from both sides. Even in this business it's the same. Even as we start to grow and we're starting to do more business related stuff, the guys are like, well, you're not better like mate, you've not been up till 9 o'clock, and that's the thing. Sometimes perception, even within your own organisation, is very difficult because sometimes even if you explain the reasons of why, it's they still need to understand and be aware of it. So the same thing applies. And again, this is all human psychology. Do you find that? Like we're always having based discussions and reliability? It's always based upon somebody or psychology or a person, not influencing, but almost kind of making someone else aware of these practices to implement. Because we can't directly do it from our side of the table. Do you know what I mean?
It's especially with reliability as a culture and changing people's thoughts and how they act. It's incredibly difficult unless you have someone driving it at site.
Yeah, definitely.
We can come in. We are essentially consultants. We can come in. We can advise. We can support. We can do as much as we can. But unless there's someone there that's able to drive with it, the minute we leave,
it is futile and it will fall down. And this is another real hard thing in engineering as well, because a lot of engineer managers, a lot of sites that we've been to have come and go very quickly. So once you start trying to get these reliability practices underway, whoever comes in, if they don't quite believe in it, kind of takes it another 10 steps back again. And I've had this with one particular customer where they were actually getting on top of it and they were really striving towards getting these things done. And new engineering manager come in, just had a completely different way of thinking and doing things. Again, there's no right or wrong answer really, essentially, in this. It's all down to perception, a lot of it, in terms of how things should be done. And unfortunately, didn't see the same vision as what we kind of did. So we was like literally out the next day. It was literally, and that's how savage this game can be. But again, it's driven by people. And if people have different ideas, you know what I mean? So in terms of what we're trying to do is try to put all of these ideas on the table
and say, kind of, how can we help?
How can we help?
What
scope can we? Because again, I think before, a lot of us had preconceived ideas of how things should be. Yeah. And the reality is, every customer is different. And we've definitely known that within our business model. Yeah. So there's some customers that just want to know the issues and problems, and they want to fix them themselves, and they want to have complete control of that. There's other companies that want to find the problems and problem defects, whatever, but they don't have the resource or time, and they want to outsource the solve part and do it in a reliable way. It's something that we've pivoted our business to be able to supply for. And there's other people that want to do this themselves. They want to carry this. They want to have this full reliability in-house. And why wouldn't they? It's such an important thing. Yep. Do you know what I mean? But it's a very difficult thing to achieve. And it has to be done in a specialised way. And we've done it. We've been really successful with it. But we've also had experiences where it hasn't been so successful because they've not been realistic of how much money was required and time's required to be able to fill the subject. Time is the big one. Time is massive.
Time is the huge one.
And that's what everyone hasn't got at the minute.
Exactly. Trying to implement a reliability or condition monitoring strategy yourself is doable. But the expectation has to be set that it's a long process, especially the training aspect. Because
massively. You can't build like a reliability unit or like company in 6 months. It's impossible. It's taken me 4 years on my own to get to get the real grassroots of what the business did.
And I think
and it took 2 years for me and you to scale it to this point now. But even with that, it was there was so many hurdles to go through. And this is again, a lot of people don't see that because we're in it every single day. And there's so many different challenges that we had to get through in terms of, and the biggest challenge for us is finding people, do you know what I mean, that know this to the level that we do. And I'm not trying to sound, like, again, we've been in the industry for a while, but it's not easy because you've got engineers that are probably better than us at other things and other sectors, of course, because they are, but they're not so involved with just reliability. There's nothing there really, is there, Will, that's trained these guys to have this understanding of mechanical and reliability, but as well the condition monitoring elements as well.
Like we've discussed before, you don't go to do high level of education and learn mechanical engineering or whatever. I did my HNC, you've done your HND. There's no topic of reliability.
No, I don't think we did one module that focused on reliability. And That for me, this is why though the training academy is so important for us. Yeah, because we've really noticed this, and we're trying to fill that gap. We're trying to create something that actually fills that gap of mechanical reliability and condition monitoring skills and observation skills in terms of being an aware engineer as well.
I think like we've got one customer we're currently on a journey with where they have said, look, we want to do this ourselves. And we're like, that's great. So we've started off collecting the data initially, which is fundamentally important. If you're one of these people sitting there thinking that you want to take this in-house, I would very recommend that you initially start with having someone to do it for you.
Just to get the ball rolling. But as well, find someone who's willing to have that transition. So when I say that transition is, okay, they're going to come in and do the data.
And set the time frame.
But they're not going to keep hold of it. Because that's a very, that happens a lot as well with a lot of companies. Of course, they want to hold onto the business. There's got to be a plan from the get-go to say, look, here's the period that we're going to kickstart this for you. Here's the period that we're going to train you and make sure you're ingesting this. And here's the handover. So the end part is, okay, we're not completely out of the picture yet, but we're gradually handing it over, stepping away. And it could be, again, I always feel there should be element of support somewhere or checking in at least to make sure everything's running smoothly. But when that engineer gets confident, but again, even if the engineer starts from ground zero, we all know that 2 years in this game is not a long time. And this is the thing, this is why constant kind of, again, for me, I've been in it for a while, but I've not been in this game. Some people have been in this game longer than I've been alive. This, and they're still learning. This is the thing about this type of reliability game that we have to understand as well. It's not, you don't just do a level 2 course. And even if 2 years experience, you don't become that engineer that knows all. You're always learning.
Because like I've always said in my head, and we've kind of worked this with this customer that we're working with, we've kind of said that realistically for them to be in a position where, so we're teaching their reliability manager, so we're teaching him reliability, and we're teaching another one of their engineers condition monitoring with the plan that they're going to create a little mini reliability department within their business. Realistically, it's 2 years for us to go from training them to doing the handover.
Minimum, I would say minimum.
And then after that, after those 2 years, we do that step away, and then it's a case of support, mentorship from afar.
Yeah.
Like, is this what I'm looking at? Because the most important thing is when you're looking at data from a condition monitoring point of view is to have, and even when you're looking at statistics from a reliability point of view, it's just to be able to have someone to go, does this look right?
I agree. That feedback bias is so important. That's how we actually learn, the feedback.
Yeah.
Do you know what I mean?
That's right.
Yes, it's right. Oh, no, it's not right. This is where you went wrong. This is where you're not seeing. Oh, okay, I see that now. And that constant feedback is so important with all of the dialogue with the customers in terms of what we're doing. Like we've just renewed a contract and a new guy stepped up and the feedback is 10 times better.
Yeah.
Already the results are just ridiculous because it's the feedback gets to the solution quicker. Do you know what I mean?
Yeah.
Because the quicker I get the feedback, the quicker there's a process of elimination or the quicker there is to get to the solution. So say, for example, we see elevated readings on a gearbox. Acceleration's fairly high, right? So then we say, oh, can you check the oil on that? Yeah, of course, check the oil next day. Yeah, no, it's low. We've topped it up. Test it again, boom. We've got to,
it's green.
It's green. Perfect. We've got that confirmation bias through feedback. That's good. We can continue to monitor. But if that feedback's long and it's
months and months.
Yeah, and it's like, oh, we go back to following month. Did you change oil on that gearbox? I don't know, I don't really know if the engineers did. I kind of told him, but I'll find out for you.
Yeah.
Then doesn't get back to you again. You're trying to, did you change it? Then next, 2 months goes down the line. He hasn't changed the oil.
Now in envelope.
Now it's in the envelope situation because there's metal to metal contact. Now you can't change the oil. You've gone too far at that point of and sometimes it is genuinely out of data that I've seen, it is that to the wire. 1 month, I said, that's the exact example that we see. We see a gearbox slightly raised, elevated. It didn't even get into envelope readings yet. It was just high acceleration, just into amber alarm. Do you know what I mean? So it was see it, raised stack in the mid-frequency spectrum, oil separation. Basically, oil's gone a bit bad or there's a lack of oil. Okay. The next following month, we told them to change the oil straight away. Didn't do it. Following month came back again. The gearbox was completely trashed. Honestly,
really?
That's how quick it can go. And again, it's an unpredictable game because we've seen these prolong and be like that for months or whatever. But again, you're playing a game of probabilities in this reliability game. You can't just assume that it's going to be okay because the last 3 that you did were. You've got to look at it as this one could be an outlier, could be an anomaly. there's such an unpredictability with this type of failure. Do you know what I mean, in terms of metal-to-metal contact? So again, the small actions are the biggest ones, you know, but that comes from feedback. We don't know what has happened if the feedback loop isn't there and if it's not quick enough. So again, it's not even what we can detect, is it? It's how quick can we respond with the small, simple things that make the biggest difference. You know, that's probably a Pareto example, isn't it? Was the 80% of the
80% of your problems come from 20% of your assets.
Yeah,
which is
an 8-20 rule.
Segue to the next podcast.
It is, yeah, and that Pareto analysis is really interesting because it applies to a lot of things in life. It's quite trippy actually when you start saying, "Oh, it applies to this, applies to this, applies to this, applies to so many different things." So that gives us to a tangent to the next podcast. We were supposed to record 2 today, but we got so into this one and we had a few technical issues, I ain't gonna lie. But we got there in the end. But guys, thank you for coming back. Obviously, we appreciate you guys.
We should probably say the next podcast is going to be on reliability.
Yeah. And what we're going to do is have a bit more of a schedule now. We're going to be a bit more organised about how we do this. So we've got a bit of an itinerary, what we're going to talk about. We want to get you guys involved. We keep saying it, but we want to now. So, you know, guys, thank you so much for tuning in. If you've watched it on video as well, thank you. Appreciate that. This is the first time we're doing this, so feedback is welcome. Do you know what I mean? And guys, have a great day.